Hello everyone and welcome to another video in WordPress code. Today we are going to learn about how to set up an RDS in a very secure way. We are going to learn what is the difference on setting up an RDS in a public subnet and in a private subnet. What are the dangers we are aware when setting up this kind of database in a public subnet. So let's look at this diagram. We do have a VPC with two subnets, a public and a private subnet, very similar to the tutorial we did before. If you don't know how to set up your own VPC in AWS, please check my last video because I will explain everything there. So this video builds on top of the knowledge I explained in the video before. So please watch the previous video if you don't know anything about private subnets, public subnets, internet gateway, and so on. But okay, let's focus to the topic of today's RDS. If you don't know, that means Relational Database Service. It is a service of AWS where you can simply set up a database, a relational database. It can be Postgre, MySQL, MariaDB, Oracle, etc. And you also have this Amazon Aurora, which is much better in terms of scaling out. You can set up many read replicas, master slave synchronization, and so on. But okay, so what are we gonna do today? What happens if you set up a database in a public subnet? Because you may do it also in a private subnet, but let's focus first in the public case. What happens if you set up an RDS here? Well, you may normally, at the beginning, I also thought, okay, why not set up a database in the public subnet so I can reach the database very simply from my laptop using the internet, right? Just using a typical connection, either using Workbench or DataGrip or your favorite MySQL or any database client you want. You just connect directly to your database over the internet and that's it. For example, here I am gonna show you a typical connection for RDS. Maybe this one, properties. By the way, this is DataGrip, very good UI for databases. I can recommend it. Properties, where are you properties? So you can set up the host. In this case, I'm using localhost, but you can connect to local databases or do some tricks to connect remotely using localhost, but we're gonna get to that point later in the video. So you set up an URL for your database, for your RDS using the credentials, user and password, database, and so on. But here's the problem. If you set up an RDS, a cluster of databases in a public subnet, it's not enough that you have credentials to secure it, but because the credentials can get somehow hammered, if they are not secure enough, if you don't use a long password, it is not, I don't know, using special characters, or maybe it's easy to hammer, I don't know, then you have a very susceptible, vulnerable database to attacks. So that's why I have this hacker here. This hacker can connect directly to the internet. Everyone has internet and try to guess the password of your database. But that's not the only problem, the only issue here. There are other issues. You may have the safest password in the world. A password with, 30 characters. So it may not even be possible to hammer it, to attack it. But what if there are a lot of hackers just messing around your database connections, sending a lot of connection requests, although they are all gonna fail because of the secure password, you may suffer a denial of service attack, a DDoS, denial of service, right? But yes, in fact, that's the problem of exposing your database to the world. Anyone can try to connect it, and even though if you have this secure password, as I mentioned, multiple retries to connect may overflow the connection pool to your database, and it may impact the performance to the real customers that are using the database. For example, your application may have timeouts trying to write or to read to the database. So how can we avoid these kind of problems? It's very simple, actually. Don't expose your database to the world. So don't put it in a public subnet, but put it in a private subnet. You may do both, but it is totally recommendable, 100% recommendable to do it in a private subnet, I mean. And that is done, you can do that here, I think. Here is this an option like, okay, public access. Are you reading this? Yes or no? By default, it is set in no, and you should leave the default in no. This is much safer because of the reasons I explained before. But okay, then, if our database is not exposed to the world, how the heck are we able to reach it? If we really want to see the data, we may not use just the internet. It is not enough. We need to use somehow an intermediate, a man in the middle, so to say, to connect to the database. And there is this concept of bastion host. Have you heard about it? It is a machine that is exposed to the world, and it is like the man in the middle to connect to the database. So this may be just an EC2 instance, a very small, you don't need a huge instance. A T2 micro may be enough to use it as a bastion host, or jump server, that is another name I've heard of, bastion host, jump servers. So this is a machine that must be in the public subnet if you want to connect to it using SSH. I'm explaining that later, but if you want to use SSH, then I'm gonna change this for SSH. Then you connect to this machine, and the machine, it is already living in the same VPC of the RDS. That is an assumption. This machine must be in the same VPC. It doesn't have to be the same availability zone. I mean. It can be another availability zone, that is no problem. In this example, both of them are in the same AC, but they don't have to be in the same AC. It's just enough that they are in the same VPC. Okay, so once you connect to this bastion host, you may connect directly to the database. And this is safer than the case before, because if those hackers try to reach this EC2 instance, first, you need the PEM, the key or the public key, so that the administrator must give you access to this bastion host. And it's very, I mean, private public keys are very secure. It is even better than just password credentials, right? You know, keys are very long, it's very long encryption methods, so very difficult to hammer with the today technology. So, and what happens if you suffer from DDoS, but this time against your machine, not against the RDS, because that's not possible, it's not exposed to the world. But what if all these hackers now try to do a DDoS in the EC2 instance? Well, your database is safe anyways. It doesn't suffer for performance issues. Your bastion host may be unreachable because of DDoS, but your application is gonna work anyway. So you may lose connectivity to this machine, but okay, it's better than the case before because your database, which is the important part of the story here in this video, is gonna work anyways. But you still have this issue. If there are a lot of people trying to connect to the EC2 instances at the same time just for malicious purposes, then what if you need urgently to connect to this instance and it is not available? You may have to relaunch a new instance, and that takes time. So, okay, this may be a border, how do you say, an edge case? Yes, this may be an edge case, but still, is there any better option to avoid this kind of problems, to avoid exposing a bastion host to the world through the internet? And yes, guys, and this is the thing I actually wanted to show you in this video, which is amazing, I think. You may also have this bastion host in the private subnet, actually. And then the natural question that arises, then how the heck are we gonna connect to a bastion host that is in a private subnet? It is not reachable from the outside, right? So you may not use SSH anymore because the bastion host is in a private subnet. It doesn't even have a public IP, right? So how do we do this? And the answer to this is the system manager. And what is this? The system manager, and not only that, also I'm gonna write it down here. And SSM agent. Have you heard about it? That is basically the system manager agent. So there is an agent. An agent is just a daemon process, a little software, piece of software running in this machine, like a process, background process that comes pre-installed in any AMI Linux images, I mean. So basically the operating system that uses Amazon Web Services by default, it comes in this operating system by default, the agent, but you need to allow it permissions. You need to set up the instance profile to allow it permissions to reach the system manager. I'm gonna show you this right now. So for example, this is my Bastion host. Actually, as you can see, it doesn't have any private public IP, I mean, because it is in a private subnet, as I explained before. But if we check what is the IAM role I assign to this machine, I can open it and you will see that I assign the permissions needed for this machine to reach the system manager. Otherwise, that wouldn't be possible. So this has a connection to the system manager, and this is basically the permission that it needs. I am using the managed AWS role. Actually, this is will be deprecated, so you have to use that actually. But for the purpose of this tutorial, you just have to understand that our Bastion host needs special roles, an IAM role, in order to access the system manager with the SSM agent. And those are the permissions that you need. The most important ones are the ones related to SSM, to SSM messages and EC2 messages, and those. And the CloudWatch metrics and stuff, I think they are not necessary for just this connection. Okay, so once you have the correct instance profile or IAM role assigned to this machine, that is not enough. As you are in a private subnet, you don't actually have instantly, internet to reach the system manager. You may reach the system manager very easily over the internet, but in a private subnet, you may not reach the outside of the world without a NAT gateway, for example, as I explained in the video before. So if you don't have a NAT gateway, but you want to reach an AWS service, you can save money, so to say, because NAT gateways are very expensive. You can save money using the VPC endpoints. Those are other features. Actually, this is a VPC endpoint. You need VPC endpoints to reach from a private subnet the system manager or any AWS service without using the internet, and it is cheaper than using the NAT gateway. And this is the VPC console. I'm going to show you where to find those VPC endpoints. You can create here endpoints. And as you can see, we do have 3 endpoints actually. You need one endpoint for each of the interfaces you need to connect to the system manager. Those endpoints are one for the SSM, one for the SSM EC2 messages, and the other one for the SSM messages. So you need these 3 endpoints in order to connect properly an SSM agent to the system managers. And how do we ensure, how can we test if the agent did connect correctly? First, there is a very easy way to check that. You just have to go to the system manager, systems. In the console, you go to the system manager, and then you go to this fleet manager option here from the node manager. And in the fleet manager, you should see an instance that is reporting as online and running like this. And this node name should be also the same name you assign to this instance in the EC2 console. Bastion v4. So this is the same instance, and it has an SSM agent on running and online. So When you see this, that means your connection worked and you may be very happy, because it's not when you try to run the SSM agent for the first time, it may be not so easy. So then, how do we connect to our EC2 instance in a private subnet without internet and without internet basically? I said that the SSM agent is the response. Then how do we use the SSM agent to connect and send commands? And there are two options. You may use your local machine, in this case my computer, or you may use just the EC2 console, and that's actually something I'm going to show you right now because it's very simple too. So you basically go to the EC2 console, you check the running instance that is your Bastion host, and you click in here and connect. And as you have seen in my other tutorials, there are two ways to connect to an EC2 instance. We may not use SSH just like that because it is not exposed to the world through the internet, but we may use the session manager. So, and that's all, that only works, I will repeat because it is very important to stress this point, only works if your instance is in the fleet manager using the SSM agent. So let's connect, and I'm gonna show you how does it look like a terminal from the SSM agent. It's pretty similar to a shell, to an SSH connection, but here I don't have privileges as sudo, so you may use ls, you may do some stuff, but if I do cd, I like to see the path, for example. So home, I don't see the path here. Well, and there are little differences, but if you want privileges, just write sudo badge, and then somehow the terminal is gonna change, and now you see the path, and yeah, you're basically there with sudo permissions, privileges. But yes, this is one way, and then I'm gonna show you how to do this from your laptop, which I think is more friendlier, but it's just a matter of taste. I'm gonna terminate this session. Don't forget to terminate the session because otherwise they remain open, and I think they may use space in your virtual machine, maybe memory, I don't know, not sure. So okay guys, now how do we do this? How do we connect from our local machine? First I'm gonna check if the camera hasn't turned off. Okay, perfect, because last time the battery died and there were like 10 minutes without screen camera. That was very pity. Okay, so how do we connect to this Bastion host, but now not using the AWS consoles we saw before, but now using your own terminal in your own local machine? Well, you have to use the AWS client. If you don't have installed it, just go and install it, the version 2. There's version 1 and version 2, but just use the newer one because I think the version 1 is gonna be deprecated somewhere in the future. I don't know when, but how do you know if you have already the AWS client installed? Just write this. I'm gonna make that bigger. AWS -- version or -- version. And there you go. I have the version 2.2, I mean. And you have to log yourself. You have to use the security credentials or whatever to get to run your proper user here in the console. And once that is set up, you have to do this to check if your identity is correct. Get caller identity, and then okay. It looks like my credential expired, so I have to log myself. I'm not gonna show that process right now, or maybe I would. I mean, there's this SSO login. Have you seen it? SSO is single sign-on. It's a new way to log users to. Actually, it's another way to log users to AWS using, I don't know, because it's the alternative to IAM users. If you have already used IAM users, you may keep using them, but I recommend you using the SSO. It saves you time. You don't have to put the MFA code, the multi-factor authentication code, every time you log in. There are some advantages, but yeah, I think the video is gonna be pretty long, so I'm not gonna show you how to log in right now. or maybe yes. Okay. Let's do this. What the hell? So I do have a script to authenticate automatically, and then you're gonna see this output. That is the result of the SSO login, and then you're gonna be redirected to the console. You just have to allow it. And yes, I'm ready. And why didn't I had to enter my credentials, my username and my password? Because it was already stored in the browser. I checked the browser as a safe browser. I mean, in my personal laptop, I may use that, like remember my account if you don't want to enter the credentials every time. But don't do that if you are not logging in a safe machine, obviously. So then you can close the window, and I am already logged, and then you can check if your credentials are already logged. And as you can see, now I'm logged in the client. And now I may open a connection. That's actually what I wanted to show you. And that is the command you need to open a connection from your local machine. You don't have to memorize this. I'm gonna show you a blog where I learned this stuff, but we are using here the SSM service, and then we use a start session. We specify the target. As you know, as you may guess, this ID is the ID from the bastion host we want to connect, right? The bastion host, the one here in the private subnet. And then what does this document mean? Start port forwarding. We do port forwarding to the bastion host, to the port 22 of this bastion host, and we expose a local port 999 from this machine because we are gonna do some magic. You know why? Okay, first, just pay attention. I opened here a new port, the 9999. It's gonna port forward, I mean, to the 22 of the bastion host. Why? Because you already know 22 will allow me to do, I guess, an SSH tunnel. Yes. And that is this connection must be left running. I'm gonna leave it like that, and I'm gonna open a second terminal, and I'm gonna show you now this is the other piece of magic. But where did I get those commands? They don't come from nothing. I read this blog, and I wanted to thank you, Chris Shannon, because this is a very well documented steps how to open an SSH tunnel from your local machine in order to connect to your RDS instance using Workbench or any GUI to connect to a remote local database. I mean, when you don't have like the database exposed to the world. So that's why you have to do all this port forwarding and SSH tunnel and stuff, so you can connect from your laptop using Workbench or whatever. So let's go back to this command. This is the second command. As you know, we did the port forwarding here, and now we do open an SSH tunnel here. I'm not an expert in SSH tunnels, sadly, but I can explain a little bit of what are we doing here. First, we're gonna connect to the 9999 because that is gonna connect us to the bastion host. The -p is port. And then what is this? That is just a local port in our machine. In the laptop, I'm running this command, and the following URL is the connection URL to the RDS. Actually, you get that connection from your RDS configuration. Here I already have a running RDS. That is the one I'm using for this demo. And if you go to your existing RDS, you're gonna see an endpoint, and that is the URL I'm pasting here. And now afterwards I write 3306 because you know that is the default port for MySQL. So we are using the local port 3388 to connect, to say, okay, everything that connects here is gonna finally connect to this thing. And that's like now whenever we use localhost at this port, our connections, MySQL query connectors are gonna connect. They won't know that they will be finally connecting to this database. So there excuse me, What I'm trying to explain is that using port forwarding and SSH tunnels, the thing is we are shortening the distance between our machine and the RDS, and finally our machine may see the RDS as it was a local database. And thanks to this magic we are using right now, by the way, I'm using a PEM. That is very important you to check. If you have to use some kind of key, you may use private public key, or PEMs, just PEMs, but you need to have a key here in order to establish a connection with this SSH. I'm using this PEM. And now that you open this SSH tunnel, this computer is gonna see this database as it were a local database connecting to the localhost 3388. And that is exactly the thing I'm configuring here. So if we now see the properties of my connection, I say host localhost port 3388, the one I opened in the SSH tunnel, user and password, just the database credentials, and that's it. And now I can query the database just like any local database. That is just amazing, right? For example, refresh. Yes, this is a very simple database. It's just a table with two names. They are strings. They are the name of my channel in Spanish and in English. But now the database connection is done. And if you don't believe me, let's enter a third code, a third name. I mean, Martin. That is just my name. Okay, let's write it to the table. And now if I do, it was written. If I do a connection now to the names, open console, is there something? Okay. Select stars from name. Let's run that thing, and now I should see 3 rows. And yes, so the connection is working, guys. The magic is happening, and we do have a very, very secure RDS. Okay, the camera is still going on. Fine, we did it to the end of the video. So what did you learn today? You learned that it's very secure to set up RDS in private subnets, and even more secure to use a bastion host also in a private subnet, and you can connect to the bastion host using VPC, I mean the SSM agent, either using the AWS console, but I recommend using your local machines so you can use any UI for database, either for Postgres or for MySQL, for whatever you may use, DataGrip or Workbench, just as any local database would do, or any public database. But now you're connected to your private subnet, which is very secure and actually, yeah, basically unreachable from the outside. So no DDoS attacks, no hammering attacks. These guys are gonna go to other places. They won't touch your databases. So that was for it. If you have any feedback or you like this kind of content, don't forget to smash the like button and subscribe. I try to upload content like this every week. If you are interested in AWS and other services I should talk about, please write them in the comments below. And I see you the next week, I think. So bye bye.